Welcome back to this video series on dimensional analysis. We talked in the past about a couple examples using distance, and now we're going to move on to examples using density as a conversion factor. So the question reads, what is the volume in centimeters cubed of 0.328 grams of gaseous hydrogen with a density of 0.089 grams per liter? So again, finding the target is the simplest. They're asking for the volume specifically in centimeters cubed. Okay, so those are my target units. Then conversion factors can be easy to spot because they've either got an equality or a slash in the units, and here density has a slash in the grams per liter. Okay, so that's going to be a conversion factor because of the slash in the units. And so the only other number that they give me in the question is this 0.328 grams. And so that must be my given information. Okay, so I'm going to set up this problem where I start out with the 0.328 grams on the left. I'm going to put on the far right the target, which is centimeters cubed. Okay, and now I'm going to take a look at the density at that conversion factor, and it may help to go ahead and rewrite it as an equality. So if I want to rewrite this as an equality, I simply write the number down, 0.089, put the first set of units listed, which is the gram, and then instead of that slash, I'm going to replace it with an equal sign and add the value 1 liter. Okay, because that is 0.089 grams per 1 liter. Now, I look at the units in my conversion factor and I'm seeing, do they match the given, the target, or neither, right? And the unit that I see that matches is the gram. The gram matches the given units of grams. So that means that I'm going to use that conversion factor first. So underneath the arrow, I've got 0.089 grams per 1 liter. So I know that that's going to take me from grams to liters because the only other unit in that conversion factor was the liter. But the problem is that I need to somehow get now from a liter to a centimeter cubed. And so here's where that memorization comes in. So I need to know the following: that 1 milliliter is equal to 1 centimeter cubed. And again, ask your instructor, but many times they will want you to have this memorized. Okay, so make sure to memorize that 1 milliliter is equal to 1 centimeter cubed. Knowing that information, I do know how to get from a liter to a milliliter. Okay, those are the metric prefixes. So I know that 1 milliliter is equal to 10 to the negative third liters. And so now I can go from the liter to the milliliter. And then my last step, I have the conversion 1 milliliter is equal to 1 centimeter cubed. Okay, so once I get to milliliters, I know that it's going to be the same thing for the centimeters cubed. All right, I am ready to set up my dimensional analysis problem. I have completed the roadmap. I'm going to start off with the 0.328 grams. Multiply, and remember it's the units on the left-hand side of the arrow that need to go underneath the fraction, and I think it's always easiest to go diagonal first. So I'm going to start out by taking from the conversion factor the grams that match the given and place that underneath the fraction. So 0.089 grams. And then the other part of the conversion factor, 1 liter, that forces it to the top. So now grams cancel, and I am left with the liter. Multiply again. Now I'm on to the second arrow where I'm converting between liters to milliliters. To the left of the arrow, I have the liters. So I'm going to find liters in the conversion factor and place that underneath the fraction, 10 to the negative third liters. And that forces the other part of the conversion factor, 1 milliliter, to go on top. Okay, liters cancel. And now last step to go from milliliters to centimeters cubed, again going diagonal. From that conversion factor, 1 milliliter will go on the bottom, and then that forces the 1 centimeter cubed to go on top. And of course, you're just multiplying by 1 to get the units to cancel. Okay, now for sig figs with this one, the given information has 3 significant figures. Remember that 0 is not important because it is considered a placeholder. But now the density matters, right? Density is a measured value. It is not exact. And so the 0.089 contains 2 significant figures. Both of those zeros in front are considered placeholders because they come before non-zero digits. And then the rest of everything else, those are exact numbers. Okay, all of your ones are of course going to be exact, and anything for your metric prefixes or definitions like 1 milliliter equals 1 centimeter, those are all exact. So the density actually limits my answer to 2 sig figs. Okay, and rounding this to 2 significant figures, you will get back 3.7 times 10 raised to the 3rd power centimeters cubed. Okay, let's go through one more density question. The question reads, the gas tank of a certain luxury automobile holds 22.3 gallons according to the owner's manual. If the density of gasoline is 0.8206 grams per milliliter, determine the mass in kilograms of the fuel in a fuel tank. Okay, so quite a bit of numbers, quite a bit of information. So again, starting with the target is the easiest. Determine the mass in kilograms. Okay, so that is my target. Now that I've spotted my target, I can start working with all the values that they give me and decide, is it given information or is it a conversion factor? And I have got the equality in parentheses. Remember that equal sign tells us that that is most likely a conversion factor. And I've also got a slash in the units for density. Okay, so both of those are going to be considered conversion factors. And then the only number that's left that has a standalone unit is that 22.3 gallons. And so that must be my given information. Okay, so I am starting out with 22.3 gallons. And I need to end with determine the mass in kilograms. Okay, now I have 2 conversion factors that I'm given, and I like to see if either one of those contain the given units. And I'll notice that that one in the parentheses, the equality, has the gallon, right? And so that's going to be the first conversion factor that I use, where I've got 1 liter equals 0.2642 gallons. Okay, so the only other unit besides the gallon in this equality is the liter, and therefore that first arrow is going to lead me into liters. Now I want to see if I can find another conversion factor that has the liters, and I don't see one. Okay, I've only got 1 conversion factor left that I haven't used, and it may help as you're going along to eliminate things that you've already written down. So I've already wrote down the 1 liter equality. I've already wrote down the 22.3 gallons. So I've only got 1 number left that they gave me, and it does not contain the liter. It also does not contain the target. That's the next thing that I would check for, and it's a gram, but the target is in kilograms. Okay, so at this point, I've got to find something in that density that seems most similar to the liter. And of those two options, the milliliter is the closest. Okay, so again, I have to know, based on memorization, how to go from the liter to the milliliter. And 1 milliliter is equal to 10 to the negative third liters. Okay, now that I'm in milliliters, then I can use that last conversion factor that I'm given in the question, which is the 0.8206 grams equals 1 milliliter. I'll have to write this underneath. So this is definitely a long multi-step dimensional problem. Okay, that conversion factor, rewritten as an equality, has the milliliters, and then the other unit inside are the grams. So this is going to take me from milliliters to grams. And then the last step from grams to kilograms, that's another metric prefix. 1 kilogram is equal to 10 to the third grams. Okay, so you do have to look for those base units, like the liter, and find, okay, do I see the base units anywhere? Which in this case, I had already used the gallon to liter, and so the only other one with the density, the closest, was the milliliter. And then, of course, the base unit of gram, you can convert to the kilogram at the end. Okay, so let's set this up. Starting with the given information, we've got 22.3 gallons multiplied by that first conversion factor. Find the given units in the conversion factor and place that underneath the fraction. So 0.2642 gallons. And that forces the other part of the conversion factor, 1 liter, to go on top. Okay, gallons cancel. Moving on to that second arrow. That second arrow, to the left of the arrow, I've got liters, so I want to spot the liters in the conversion factor, place that underneath the fraction, 10 to the negative third liters, and that forces the other part of the equality, 1 milliliter, to go up top. Liters cancel. Now to go from milliliters to grams, again, find to the left of the arrow the milliliters in that conversion factor. So the 1 milliliter will go on bottom, and then the other part of the equality must go on top, 0.8206 grams. Okay, milliliters now cancel. And then my last step, to the left of the arrow, I have grams. So from the equality, I'm going to take that 10 to the third grams, place it underneath, and then forcing the 1 kilogram from the equality to go on top. Okay, now sig figs. So the given information, that has 3 significant figures. And then we've already talked about how density is not exact. Okay, so the density way over here, that 0.8206, that's 4 sig figs. And the other conversion factor that we were given in the question, 1 liter equals so many gallons. Again, we're going between the metric and the US system, right? You got metric on top, US on the bottom, and it's not the 2.54 centimeter exception. So this is not exact either, and therefore that is 4 sig figs. Okay, so the least is our given information, and oftentimes that is what happens. We need to limit our answer to 3 sig figs, and we get 69.3 kilograms. Okay, I hope this helps. In the next video, we are going to look at where we start off given information as a fractional unit. Okay, so this does kind of change things a little bit.